All right, hello everybody. We're going to go ahead and get started. I have the honor today of doing the introduction. For those who don't know me, I'm Katie Allen. I'm a staff scientist here at the Institute, and I have had the privilege of working with today's presenter for 17 years now. I did the math this morning. No, we haven't aged a bit. No. Dr. Shaun Grannis is our current VP for Data and Analytics. When I started working with him, he was just getting started in a career that has now made him nationally recognized for record linkage, among many, many other things. And he's going to be talking today about a topic that's near and dear to my heart, which is the intersection of EHR, public health surveillance, and AI. So without further ado, Dr. Shaun Grannis.
All right. We have the CME requisite CME things. Now, I wonder this up here for an extended period of time so people can read through the whole thing. And if you don't agree, should you leave? Oh, my lapels. No. All right. Yeah. All right, and then that's it. So here's what we're going to cover today. Within these topics, I'm going to talk to you about how we pull EHR data and make it usable for a number of use cases that involves AI and other models. Regenstrief, as you all know, has been working with EHR data, messy EHR data, clinical data for many, many decades. Using AI is no different fundamentally from the data perspective. We still have messy data. It still needs to be extracted, formatted, cleaned, and then it has to go back and be extracted again and formatted and cleaned when you recognize you didn't quite get the query right. And then by the fourth or fifth time you've gone through this iteration, you probably have a decent data set. What I just said is true regardless of whether or not we're talking about AI and advanced analytics or not. The last Friday, the Kelley School of Business hosted a healthcare and AI conference. And at that conference, we heard from various practitioners and business owners who are beginning to think about AI. And one of the key points that I would take away from that is in helping to demystify, AI is just another tool in the toolkit. We've had logistic regression for a long, long time. That is an analytic tool in the toolkit. We've had neural networks for a while. We've had Bayesian networks for a while. We've had lots of analytical tools in our toolkit. AI, from the simplistic perspective, is just another tool. And so as we think about how to use it in our work as researchers, as practitioners, as implementers, I think it's important to recognize how AI plugs into already existing processes and patterns for us. I want to talk to you a little bit about some AI updates. The field is moving rapidly, and I think it's super important to keep track of what's happening there. I've said this now, I think two times from this podium. I think this is my third time saying it. I believe that everyone in this room should understand how to use AI, not necessarily for research and analytics, but for your daily tasks. It does a very good job of processing information for those of you who have to go through potentially hundreds of emails per day. AI can be very helpful for that. For those of you who have to draft documents, AI can be very helpful for that. For those of you who need a creative inspiration, AI can be helpful for that as well. And so I would encourage you all, and in fact, I would encourage the leadership of Regenstrief to think about an approach to getting staff trained. Now, there is a CTSI session coming up that Titus is leading, and Coasley Simon, I believe, on AI and some practical approaches and how to use it effectively, while at the same time keeping Tony from having to use his Tums for the heartburn he gets when he thinks about security. But there are ways to use, I think, very clear and obvious ways to use AI that are super important. I'm seeing people become extremely efficient with their work by using the tool. And I'll repeat, Newsweek has a great policy for AI. They say nothing about AI. They say that their employees are responsible for every word that they write. They're responsible for every product that they produce. And I think that is still true with AI, but AI can move you along faster. I want to talk to you about some AI updates. I'm going to talk to you about this concept, something called agentic AI, a concept called natural language query. I'll explain these as I go through chart summarization. These are activities that are beginning to gain traction with attention and energy, ambient listening, phenotyping. Has anybody heard of phenotyping before? Is that something we do a lot? I'll talk a little bit about patient-familial relationships, and then if we have time, chatbots. So first of all, the AI updates. You notice I deliberately chose this image. Why do you think I chose this image? What does the image show? Yes, that's right. I view AI as an augmenting tool. Now and for the foreseeable future, I think that AI, there needs to be a human in the loop for any critical decision or critical content that you create. In fact, AMIA, one of our professional societies, actually has a position that there should be human in the loop routinely on that until it's proven that you don't need it. So for now, AI is an adjunct. It's an add-on to what we do. So the AI updates. The FDA has an initiative to phase out animal testing. They announced plans to reduce the use of regular animal testing and adopt new methodologies, including AI-based models. So they would like to develop techniques to accurately model animal systems. And so they have a pilot program launched. A large trial organization called Worldwide Clinical Trials they're one of the largest patient recruitment organizations across the globe. They've just begun implementing AI into all of their patient recruitment efforts let's go back here, to patient recruitment. I don't know if you all know this, it's probably obvious. Recruiting patients, incredibly expensive. When last I checked over 10 years ago, it costs around $18,000 to recruit a single patient. So now with inflation and everything else, you're probably above $25,000, $30,000 to recruit a patient. So the fewer misses you get, meaning the fewer patients that you pursue that turn out to not be eligible or unable to participate, the more efficient, more cost you save. And so people are beginning now to build some AI models into recruitment processes to minimize the false positives or the ensure that who they're getting is appropriate. Next, and this is, all of these are within the last 4 weeks. You can How many of you are trying to track what's going on in AI? I see one hand. David, 1, 2, 3. Okay. Only 3 people. So the rest folks, so how many people are interested in learning more about AI but don't know where to start? Okay, good. There's more hands. Well, if you have time, go to YouTube and type in what's happening in AI. There's a lot of good potential resources there. Again, I think that, obviously there's a lot of self-learning that can happen, but I do think projects like what Titus and Coastly are working on are important. Clinical development of new molecules. An organization just described some new significant results in being able to phase 5 is the name of the organization, phase V. They demonstrated the ability to accurately predict molecule function, right? What do drug companies do? What's, one of their main sources of investment and cost is in creating new chemicals and trying to figure out whether they have value, particularly in the human body. So if you can predict without as much experimentation, if you can predict what that chemical does, you can eliminate a lot of cost and move much more quickly. So there's some exciting work going on there. In addition to looking at minimizing the laboratory animal model approach, AI has released some draft guidance for AI in clinical trials. So how should AI be used in clinical trials? And so for any of you interested in AI policy, interested in clinical trials and what folks are thinking about, that would be a good read for you. If you're having trouble falling asleep at night, you can pick that up and take a look at it. And then, so we've done trial. There were a couple of successes over the last month in clinical trial innovation. There's another product now that when you recruit patients, you're usually following a clinical protocol, right? There's some sort of experiment that you want people involved in. There are sometimes there's efficiencies to be gained on how you approach patients, how you select patients, how you identify them. But there can also be efficiencies with tweaking your protocol to, if your protocol doesn't apply to a given population, if you're recruiting from an area that isn't consistent with your protocol, there's now AI that reconciles protocol with your recruitment process and tries to optimize the protocol to ensure that patients are appropriately selected. So these are some examples, and I on my title, I call this the messy middle, okay? These advances aren't things that you're necessarily going to see on the front page of the New York Times. These are the day-to-day things that happen behind the scenes, cost a lot of money, that don't necessarily work as well as we'd like, but we're seeing a lot of innovation going on there in terms of the middleware, in terms of that activity inside the organization that ultimately produces something that might get to the New York Times. And so that's where we're seeing a lot of innovation. And if you're not tracking that middle space, you might be missing out on a lot, because these innovations won't ultimately just apply to what happens, in the back offices. behind the scenes, but they may actually become methods and approaches that we might want to use in our clinical research. So anyways, I think it's important to keep track of what's happening with AI, and these are just some examples from the last month. By the way, most of the images in this presentation are generated by AI. And in fact, let me show you, let me prove that to you here. So you'll notice there's a square here. I can't move it, can I? There we go. So AI put patient-driven recruitment on there twice. And so I had to hide one of them because so you see there's, you can use AI, it's not perfect. I'm responsible for the product you're seeing, right? So ultimately that's what we need to do. So agentic AI, let me take a sip here. By the way, did you guys see the bridge is open? That's exciting. How many people have gone over the bridge? Very good. Titus took his first bicycle ride this morning across the bridge. Exciting times. Will allow us to be better connected with our friends over at 16 Tech. Agentic AI. So the way AI is being used commonly right now is we have a model. You build a model to do a certain thing, and then you apply that model. You have it do the certain thing, provide it the inputs you design the model for, and you hope for the outputs the model produces. What we're starting to see now are agent frameworks. So agent is really another name for model, but agent apparently sounds cooler in marketing material maybe. But now we're seeing frameworks being developed where one AI performs one function and then passes its output to the next AI, to the next agent, to the next model. And it then has a specific task different from the first. One of the examples I saw was, so you have models that can write copy for blogs or for newspapers right now. And you might say, well, yeah, that's generative AI. You ask AI to write something and it'll write it. But if you want to produce the highest quality possible content to put out there, what you might want to do is say, have the first agent do some research, some background research on the topic you want to cover. And then you might hand that off to the second agent that creates a framework, an outline, or a rough draft of what you want to write based on that content. Then you might have a third agent that becomes the copy editor that actually looks at the output from the second to validate it and make sure that it fits the specific requirements for the blog. So you can see that there's multiple agents being strung together now, handing off and communicating with each other. You could even imagine a feedback loop where you go from the copy editor back to the second agent to write, and so on and so forth. So, and we're seeing that outputs become more useful. You could even, so one agent or model, it's a neural network, right? Large language models are neural networks with lots of nodes being connected to each other. So now we're starting to see this scale developing, where you take this single collection of nodes connected to each other, producing a single purpose, to now taking multiple collections of nodes, doing multiple purposes, and plugging them together. And so you can see a higher order coming out of this. And so I think it's important to keep track of what's happening with agents. I'm going to give you an example that's actually a research idea that I'm working on with a researcher from IU Bloomington. So, and this is where the agent framework becomes practical. So de-identifying free text, right? Hard problem, impossible problem, many believe. It's very difficult to take a clinic note with protected health information in it and try to remove all of those 19 HIPAA identifiers. Software after software has tried, study after study has tried, and everyone admits you can get to a certain level, but it's challenging. Well, there's a new approach to try. And that approach involves at least 2 agents, at least 2 models. The first model, you train just like you would any other de-identification tool. You train it to recognize protected health information. It removes it and then outputs the de-identified free text. But you don't stop there. You hand that output then to a second model. What does the second model do? Well, before you put the second model into play, you take the output from a training set from the first model. So you give it, say, 100 unstructured notes. Have the first model de-identify it. Then you have human reviewers go in and look at those 100 notes and say, whoop, you missed this, that's wrong, this is good. And then you train the second model to identify the documents where the first model is going to make a mistake. So you can actually train the second model on the errors from the first model. So it can become, the second model becomes a detector of errors, right? And once you have a high likelihood suspicion that, whoops, this isn't going to work, you can pull that out. What do you do with it? Maybe you, in your agent framework, maybe you feed that to a third model whose job is to tackle the really tough ones. Maybe you create multiple models to look at each, maybe there's 19 models, each looking at one of the types of HIPAA data. So there's a lot of potential solutions and approaches to this. Will this turn out to be perfect? No, I don't think so, because as many of you have heard me say, back when I was doing some work with chest x-rays, I came across a report that said, the radiologist, bless his soul, said, and incidentally, this happens to be the tallest woman in the world. And that tallest woman in the world used to live in Shelbyville, in Indiana. She's since passed away. But phrases like that are almost, say impossible, but they're almost impossible to deal with all of the creative ways that human beings can identify. But my primary point here is we're not just using single models anymore. We're not just training and saying, hey, do this and give me the output. We're now starting to think about what do workflows look like and how can we get these models to interact to produce the best possible output. And that's another important thing that we need to be thinking about as we consider the use of AI in our work and in our research. I already gave you the de-identification example. I want to move on to natural language query. So on my Regenstrief website, there's a quote that goes something like, humans are best at being humans, and we should use technology to allow humans to be humans, right? To interact with one another and not sit in front of a keyboard. I think AI has already begun to go a long way towards allowing physicians to allow care providers, instead of turning their back to the patient and typing and then looking and typing and completely skewing the doctor-patient relationship. We're starting to see AI enable us to start ignoring the technology, start letting the technology drift into the background. So with natural language query, right now, if I want to know what my patient's last hemoglobin A1C is, they're diabetic, we always check hemoglobin A1Cs. What's their last hemoglobin A1C? So now I click A1C, click. Let me scroll through this. There it is. Great. We want to get rid of the need to use the keyboard. We want to be able to say, when did my patient last have a hemoglobin A1C? And we can pass that question to a large language model that has access to the patient's chart. And it can do the scanning much faster than I can to find the answer to the question and bring that out. There's the answer. There's the value. Would you like a graph of their historical values too? That's certainly possible. So natural language query is about getting rid of the clicking and being able to communicate like human beings do. There's a phenomenon. Have any of you heard of vibe programming? Vibe programming is the new way to write programs using AI. You talk to it using natural language. Write me a program that generates the first 100 prime numbers. AI will do that for you. And you have the program and you can run it and it'll do it. It'll generate it. Write me the HTML and CSS code to create my own personal website. And I would like this content on it. AI will write that code. So that's an example where we're using natural language to accomplish something where we've had to touch the keyboard before. Now, the code's not perfect. If you're interested in doing that, the Anthropic Claude tools, C-L-A-U-D-E tools, are the best for coding. OpenAI does a good job. Gemini does a good job. Grok is okay. But in healthcare, imagine this ability. And in particular now, imagine we have a health information exchange where patients are seen in lots of different places. And you might not know everything about all of the care that your patients received. They might be sitting in front of you right now, and you might want to be able to say, I'm seeing this patient right now for chest pain. Give me any relevant information from the health information exchange that might influence or impact chest pain. Give me their past medical history, their medications, their recent ER visits, etc. That is a query that you can ask of AI to perform with healthcare data. And so natural language query is important. And in fact, the industry team, Jared Baker, Jamie Thomas, myself, we are over the next year going to be vetting different software tools for chart summarization. Oh, I jumped ahead. For natural language query. And we're also going to be doing chart summarization, which is a very related topic. A chart summarization might be a default report that you want run on every patient. Or, Titus, you might say, I want a cardiovascular summary of my patient, and it should include X, Y, and Z. Again, all I've done is use natural language. I can store that prompt. And so every time I see a patient with some sort of cardiovascular history, I can run that prompt on the data, retrieve the information. Now, I think there's a lot of research to be done in this because we don't know exactly how that AI is going to behave. Is it going to produce too many squares on the image? Is it going to miss some squares on the image? Is it going to miss some diagnoses, some medications that are there? We need to learn all about this. So these are, I think, exciting possibilities. And chart summarization, just very basically, is you take all of the data from the person's chart or from a population's chart. This doesn't need to just be one patient. You could summarize entire populations, generate the appropriate prompt, or maybe this isn't just a single prompt, maybe this is an agentic framework, right? Where you have multiple agents working to ensure that you're pulling the right data. So chart summarization is another function that is getting a lot of interest and attention right now. What gives me hope for the chart summary and the natural language query is the phenomenal success that is being had right now with ambient listening. What is ambient listening? Again, let the humans be human. You walk into a room, there is a recording device. That recording device is listening. It will parse and process that information and feed it back into the EHR for the physician to review. How exactly does that work? A little bit more detail. So there's conversation capture. So one of the things that I think goes undersaid with the advances in AI that we've seen is essentially human voice recognition, natural language processing. It's solved. It's done. It works. It works better than any human can recognize text. Now, AI does make a mistake when it hears you. Sometimes you've got a bad mic, the audio is wrong. But if you have the appropriate setup, AI will recognize your voice and the words you're saying better than human beings can. And back when I was a fellow in early days, any of you remember Atif Zafar? Yeah. So Atif worked on natural language processing. In one of the papers that Atif worked on with Clem, McDonald, and Mark Overhage, I still remember this phrase to this day. It was Clem's. Voice recognition is always and will always be 5 years away. It's not 5 years away now. It's a done deal. It works. So with ambient listening, we're using large language models to hear the voices and to transcribe what's being said. But there is a human in the loop. On the receiving side, I don't know if you've heard of Dragon Ambient Experience or DAX. DAX is being deployed across the country in many healthcare systems. It's being deployed at that place over there, Eskenazi. I believe it's being deployed at IU Health. My wife's practice has it as well. So my wife walks into a room. She now uses her phone as the listening device. She used to have one of the, remember the iPods? Yeah. The support for the iPods ended last year, so she couldn't use the iPod anymore. Support by Apple. So she walks in the room with a phone in her pocket and she starts talking to the patient. That voice, those words are sent to this middle person at Dragon Ambient Experience who watches the AI transcribe in real time, corrects it if it needs to, and ensure that the information goes into the appropriate place in the chart. Once the AI plus human on that end is done, they feed that information into the chart, goes back to my wife, she reviews it and signs off on it. My wife's story is not unique. Before DAX, she would spend at least 3 hours a day after work finishing her charts. At least, it's not an exaggeration. Now she leaves the office with her charts complete. So she's literally, this is where AI literally is giving people back time in their life. And that's phenomenal. I think it's the greatest success we've had in any healthcare technology in, at least in my career. So very powerful. If ambient can work, I think some of these other use cases can also work. What we have to figure out is, can we do chart summarization and natural language query without a human in the loop? That's the big question. All right, moving on. Phenotype inferencing. Okay, we create phenotypes all the time. We have, what is a phenotype? A phenotype means it's the inclusion-exclusion criteria for a particular cohort. I want to find people with uncontrolled hypertension. How do you define that? I don't know. There's, you can use one of 57 different approaches to creating phenotypes, from exact match rules to using, decision trees to using neural networks, et cetera. But phenotypes, talked about a lot in our work, is essentially the way to identify a particular condition or outcome in the data. LLMs have great potential to perhaps take over most of the 57. That just shows that number out of the air. Take over or replace most of or many of the 57 approaches. We are using AI in several projects to effectively generate phenotypes and test their accuracy. So I think most of you have heard me talk about notifiable condition detection. So very quickly, every state in the United States is required to report notifiable diseases to public health. Those notifiable diseases can be sexually transmitted diseases like chlamydia, gonorrhea. They can be foodborne things like salmonella, norovirus. They can be things like COVID. They can be, sometimes there's special conditions, like if it's Staph aureus, the Staph aureus has to be invasive. That's reportable. If it's lead, any lead test in Indiana is, whether it's high or low, normal, goes to the state. So there are lots of reporting requirements. Physicians, hospitals, and laboratories are required to report. They don't. Study after study have shown that they report around 10% of all conditions. One of the things that frankly Regenstrief is a leader in is in the space of notifiable condition detection. We've proven that automated systems do multiples of times of reporting notifiable diseases. And they're really easy to maintain, aren't they, Shahid? Yeah, Shahid helped, and many of you in the room have helped work on the system. It's a complex system to keep up and running. You're always chasing the healthcare data that's always changing. But there's a chance we might actually optimize this as much as we possibly can. What we've done, we've taken a large language model called Mistral. We have taken HL7 messages, laboratory messages, some are reportable, some are not. And we created a new hybrid, dare I say, Frankenstein model. No, it's not Frankenstein. We created a combined model that now has not only, so this model knows a little bit about HL7 laboratory tests that are reportable. This model knows a lot, okay? And we gave it the knowledge by having it read HL7 messages and provide appropriate responses. And Andrew Martin has been helping out with that. So the workflow for notifiable disease detection, which all of you are aware of, participants in the Health Information Exchange send data to the Indiana Health Information Exchange. We have a notifiable condition detector that runs there and identifies positives and negatives right now. That detector has been studied over and over again. It identifies more, but it's not perfect. It misses some, and it does generate a small number of false positives. And so we want to improve its accuracy. But this is the typical flow right now. Now, what also happens right now is, and Tony, you can tell me how long we're still going to do this, but we capture the HL7 messages that are sent into the Health Information Exchange, and we store them on the Scholarly Data Archive. Are there plans to turn that off anytime soon, Tony? The answer is no. Are there? Okay. So anyways, Scholarly SDA is free to us, isn't it? Other than the cost of the personnel who have to. No, it's not free? Okay, we can figure that out later. Okay. Scholarly Data Archive has everything. So we can find negative, non-reportable laboratory results there. We can combine that with positives from the notifiable condition detector. We then, as I mentioned, we fine tune, we create the Frankenstein monster. Not Frankenstein. We create the fine-tuned models, and then we test them. Created 4 models. And we looked at 3 conditions: chlamydia, gonorrhea, salmonella. We created 3 separate models for each, and we created a 4th that combined all 3 into a single model. With the individual models, we can ask, is chlamydia here? Is gonorrhea here? Is salmonella here? With the combined model, we can say which condition is here, or we can continue to ask the specific question, is chlamydia, gonorrhea, salmonella there? What we found, and we compute the accuracy results. What we found was, and this is, I think, good news for maintenance, Shahid, we can actually bake all of the conditions, at least we could bake the 3 conditions into a single model. So we're only dealing with 1 model to have to update and manage. And then we just ask questions of that single model, and it produces If you look at the combined model, so for example, I'll just walk you through this. So a non-specific prompt is, what condition is here? A specific prompt is chlamydia here? Or is salmonella here? So you can see when we use a specific query with the combined model, we get, well, F-score, we get an F-score of 0.983. Look at single model specific, it's 0.987. I mean, it's almost identical. And so why create 3 specific models when a single combined model can do just as good? It'll minimize the maintenance and support of that. Now, these models will need to be retrained periodically because the data changes. So that's some fun work that we're doing right now. Also, Titus, this is a reference to Titus Day. We're also working both locally and with colleagues at the University of Colorado on patient matching and familial relationships. You can match a person to themselves, but you can also match a person to their sibling. You can match a person to their parent. You can match a person to their spouse. You can match a person to a home unit, meaning people that live at the same address. We've built decision tree models, XGBoost models with this, but we're able to secure some funding from PCORI as a supplement to look at using large language models for this task. We're in the developmental testing phases right now, but we are hopeful. I actually, when the concept was first described to me, I thought, large language models aren't the right tool for this problem. But I'm beginning to see from some of the results in the discussion that it's possible that large language models might actually be helpful in matching patients to themselves and to others. So more to come on that. We're super excited about that. Finally, the last, it's almost obligatory to mention this. Many people are thinking about how they can get patients to interact with large language models to schedule appointments, to understand what a test result means, to learn more about their condition. We're working with a team right now to pilot a chatbot that will help people who are upregulated or downregulated, meaning that they process a medication too quickly or they process it too slowly, or they don't, faster than normal, less slower than normal. Those have implications for how well the medication works for them. If you respond to it, if you metabolize that medication slowly, it can build up in your body, right? If you keep taking it on a regular basis. And so you need to modify, you need to adjust the prescription based on their genetic profile. Well, there's a group that's interested in providing a tool to patients who have tested positive for these conditions to enable them to explore their condition and ask questions. It's going to be mostly an observational pilot over the summer, hopefully in preparation for a larger grant proposal, to understand what questions the patients ask. How accurate is the chatbot? How favorably was it received? And we can ask that both of patients and of providers. So more to come on that. We are at the end of my talk with about 10 minutes left. Time for questions and answers if you'd like, or we can all get 10 minutes of our life back.
We have a comment from earlier from Randy Grout. He said, tiny correction about ambient at Eskenazi Health. We are piloting vendors, one of which happens to be Nuance's DAX product.
Okay,
He just wanted to clarify that.
great. Come on, Randy, you want to go with DAX. Everybody else is. No. Other questions, comments?
Hi, good afternoon. Just wanted to know about how you are teaching AI. I don't really understand the process of how you went from the first model to the fine-tune model? And then in the same with the family linkage, like what are you teaching it and how do you teach it? Do you use AI to teach it?
Yeah, good questions. What's your name?
Jasmine,
What do you do here at the Institute?
research specialist, CHSR.
Okay, cool. Get her involved, yeah. So your first question was about how are we teaching this? Well, we're learning how to teach it, like I'll say it for the third time, Titus and Coastly are putting together a course that many of us will be a part of. I would also say an important question is how can you learn about it, right? And what do you do there? The internet changed the way we educate ourselves. And in fact, AI is changing the way we can educate ourselves. Very often, I do this almost all the time now. There's a new article that's come out. I take the PDF of that article, I upload it to AI, and I say 4 letters, ELI5. What does that mean? Does anybody know who hasn't heard me say it before? What's ELI5? Does anybody know what that is? Yes, exactly. AI understands ELI5 because people on the internet use it. You go to Reddit or other places, people say ELI5. I just want the simple explanation. So upload the PDF, ELI5, boom. My junior in high school, my friend's 12-year-old can understand at a high level what that research paper is about. You can even go up, you can do ELI10, ELI20, or you can start querying the paper to understand things. There was a paper in my field of record linkage that I knew had an approach that solves a tough problem in my field. I had that paper for probably 7 years. I had some biostatisticians read it. They couldn't quite parse it out. I put it into AI, and in about 7 minutes, I understood exactly what they were doing. And then I said, why didn't they make that clearer? My gosh, they're computer scientists. What do you think? I think there's a great opportunity for, you can go to an AI and say, how do I fine tune a model? And you can keep asking questions until it explains it the way you need it. You never understood differential equations, now you can. Because you get to ask the questions the way you want to and ask for a response in the way you respond best and understand best. So I think it's incredibly powerful. There is a voice feature in ChatGPT. I'm not encouraging anyone to buy it. This is not an encouragement, but hey, can you tell me about quantum physics, in particular, the Einstein-Rosen bridge?
Sure. Quantum physics is the branch of physics that deals with the behavior of matter and energy at the smallest scales, like atoms and subatomic particles. It introduces concepts like
Okay,
wave
stop.
particle.
That's good. If I were involved in clinical research and I wanted to start learning about how to fine tune large language models, where should I begin?
Great place to start is by understanding the basics of machine learning and natural language processing. There are plenty of online courses and tutorials that cover these fundamentals. Once you're comfortable with those concepts, you can explore frameworks like Hugging Face Transformers Library, which makes it relatively straightforward to fine-tune.
Okay, stop. You're in front of a group of clinical researchers. Do you want to say anything to them?
Absolutely. I'd say, welcome everyone. It's an exciting time to be in clinical research, especially with the growing role of AI and machine learning. Fine-tuning large language models can unlock incredible insights from your data, improving patient outcomes and driving innovation. Embrace the learning curve, collaborate with your peers, and don't hesitate to dive into these powerful tools. The future of healthcare is in your hands.
I didn't even plan on doing that, but I thought, hey, why not give it a try? I mean, that was not tested before. So there, this is an encouragement for you all to consider how AI can help make your life more efficient, get you back some time in the day. Yeah, Titus.
Yeah, thanks, Shaun, for the shout out about the AI workshop series. I wanted to tell you guys a little bit more about it because we're constructing it right now, so you know what's going to happen. So quite a few people came to us over the last couple of months and said, you know, how can I learn how to use AI in doing X, doing research, doing education, in clinical care? And we got that from lots of different places. And so everybody was like excited, yeah, let's make some huge AI education effort. And I'm like, okay, let's be organized about it. So we actually did some background research. We got people involved, ranging from the library, from the School of Medicine, the Fairbanks School of Health, the Luddy School of Informatics. Xiaofan is actually helping us. So we're putting together this very practical series, and Shaun today did a great job at kind of really talking more about the practicality of these things. And we're going to start with 4 or so workshops this year. So that'll be, you know, in the next couple of months. Shaun, you'll be one of the people. Kosali definitely will be one of the speakers, and, you know, we'll get 2 or 3 more. So one thing that you guys can do that really helps us is to email me or Medina to say, here, I want to know X. You know, I'll give you some examples. So one person asked us, how do I use AI to construct systematic reviews? You know, some of you might have done systematic reviews, and you know, it consists of a big process, reading lots of papers, marking up passages in papers, and, you know, that can get tedious. And so the question is, how can AI help you with this? So I'm actually starting to explore how we can use it in a scoping review. So a scoping review is kind of your lowest level of systematic review. It's not very structured, doesn't have as many rules, but that's one example, okay? Shaun said the other day, well, we shouldn't teach people how to use Copilot in email. I agree, you know, that shouldn't be us. So I'm trying to rope you into doing some basic training on these office tools. How do you use AI well to create graphs? How do you use AI to create videos? You can do all of this, you know. And so whatever you guys are struggling with, or after Shaun's presentation, what you're kind of wondering more about, just email us. We'll put it on a long list, and this workshop series will probably never end. So thank you.
Okay, we have one comment from David Hegstrom. My understanding is that IU Health very recently transitioned from Suki to DAX for ambient technology. Chris Beasley asks, what do you think about hallucination issues in clinical AI, especially subtle errors that a busy clinician might miss?
So that is an issue, and we need to come up with solutions to identifying those. I think part of the solution is going to be the agent-based approach. Often what I'll do, if I want to make sure that I'm generating something factual, I'll generate the output, and then I'll ask a separate model in a separate window without the same memory, so it's uninformed, it's uncontaminated. I'll say, hey, I want to generate content X. Here's an example of that. Can you look for any factual errors, or how would you improve it? And that way, it often can catch those hallucinations by just having multiple, quote unquote, eyeballs on it. It is a problem. There isn't a one size fits all solution, nor even a guaranteed great solution to that right now. But given the increased knowledge and understanding of how AI behaves, hallucinations in general are getting better, but they're still there. I mean, I've seen it. It's still, AI generated a false reference for me the other day. And so they're still there. Humans are responsible for the content that they create. If they're using AI, fine, it's a tool, but you're still responsible for that content. Physicians are going to be responsible for the content that they review and the information that they make decisions on.
Jeff Warble just commented, my computer is listening to this talk. I just got this email. Study. Ambient AI reduces burnout documentation time.
Well, that's freaky.
And then we have another, we have a question from, let's see here, from Randy Grout. I just read an interesting article about how physicians can calibrate how much they should trust AI in clinical care and how that affects liability and stress. You have to kind of trust it because it is so powerful and accurate, but you have to be skeptical because you're responsible for the final decision. What are your thoughts on this? Which I think you've said. What do physicians do between this rock and a hard place?
I still think there are evidence-based best practice approaches to this that don't exist yet. I do think, Randy, that I would want, in addition to what the AI declares to be true, I would want to know why it thinks it's true. So there's a question I love. It's called, I call it well, I don't. It's called the Columbo tactic, and that is, Columbo, the old detective, he would come along and say, I'm just a bumbling old man. Why do you think that's the case? And asking people or AI, why do you think that's true? How did you come to believe that? I think we need to do the same thing with AI in order to make sure that the conclusions it's drawing are drawn from true premises. So. All right, we are at time, we're over time. So thanks, everybody.